So this is question 8 on page 57. Okay, so we've been given some information at the top and we've set out with a table, which is often quite easy. Sometimes easier than just using formula sometimes as well. So what we know is the probability of A dash, so here's my A dash column here, is 0.8. So we know that that total probability is 0.8. I know that the probability of B dash, so there's B dash there, so that whole column must add up to 0.55. Now, these bits in the middle within the square are all the intersections of it. Now, we've got want the probability of, we're told the probability of A dash and B dash is 0.35. So here's A dash, here's B dash, so that must be 0.35 in there. So we know that this has to equal 1. Okay, and we can work out the bits of probability that are missing, hopefully. We know there must be 0.45. Because 0.45 plus 0.35 equals 0.8. We know that that must be 2, because 0.2 plus 0.35 equals 0.55. Just subtract it away from the total. You'll find out what's left. That has to be also 0.2, because 0.2 plus 0.8 equals 1. So that must be 0.45, because 0.45 plus 0.55 equals 1. Now, so this must be 0, because 0 plus 0.2 equals 0.2. So 0 there and 0.2 there has to equal 0.2 there. Okay, so are they mutually exclusive? If you can remember back, think about a Venn diagram. Mutually exclusive is when they don't intersect. So that means the probability of A intersect B equals 0. So what we're going to do here is look and say, right, is there a probability of A intersection B? So here's A, here's B. Is there any probability in there? No, there's not. So they are they are mutually exclusive, because my intersection of them, i.e. the probability of them both happening, equals 0 from inside that table. What's the probability that A and B occur? Okay, so we want both A and B dash. Here's A and here's B dash. So where those two intersect, so we could actually write it, so probability of A intersection B dash, because we want both of them occurring, is 0.2. And that comes from that little box there. Now, we want the probability of A dash happening, given that B already happens. Okay, so we want a whole probability. So we're going to just look at the probability of B happening. We are just looking at that box there. We are just looking at the fact that probability is B is happening. So out of that box, the probability of A dash happening is this 0.45. Out of the whole probability, which is probability of B, which is 0.45. And if you divide those two together, you equal 1. And this comes down to question E. What's the meaning of that previous answer, the factor 1? It means that all of A dash must be in B. B has nothing else in it apart from A dash. It's got no A in it, because that's where we looked at the probability being 0. So the meaning of your answer, all of B is A dash. And that's pretty much what it means. Hopefully that makes sense.